So your grandmother needs help. Let me erase this. She has $50,000 to invest. Part of this is to be invested. I'm gonna write some of this over because I didn't write it neatly enough the first time. Some of this is to be invested in non-insured bonds paying 15% annual interest. The rest of this money is to be invested in a government insured COD paying 7% annual interest. She needs 6,000 in extra income from the investments. How much should be placed in each? I'll give you a chance to write it for those who are going to write it.
So each homework goes with each class, or will
Or will?
what did I didn't know that I did. What did I stop at? Did you
You
repeat that?
said does each homework goes with each class?
Yeah, or will like two homeworks go with one class one day?
Oh, well, it just depends. Like last class we did 1.2 and we did hold on, let me make sure. Yeah, we did 1.2 and a part of 1.3. So it just depends on the complexity of the problems and if people have questions that may slow me up, all of that just depends on what we will cover in a day.
Okay,
Um,
thank
but what the way your homework is broken up is by section. So these problems right here will be in section 1.3 and just in 1.3. You know what I mean? So your homeworks are just broken up according to your sections, not necessarily according to the lecture. All right. So let's look at how we'll set this problem up. So remember, we talked about last class how when dealing with word problems, your setup is going to be one of the most challenging parts. And then actually, doing the equation for most people, once you have the equation already set up, then you're good to go and where to go after that. So we have a grandmother who needs help. She has $50,000 in total to invest, and she wants to invest it in two different types of accounts. One is non-insured bonds paying 15% annual interest, and then the rest of it she wants to put in government insured CODs paying a COD paying 7% annual interest, and she needs $6,000 in extra income by making these investments. So how much should be placed in each? So we're going to break up, and I'm going to erase this so we can talk about it. But we have two accounts, one at 15% and one at 7%. That's the main difference between the two. One account 15%, the other account 7%. Also, we're going to lean on right here the simple interest formula. And I should have put that first. Wherein if I want to know how much interest is going to be earned in an account, I would do your principal times the rate times your time, PRT. Principal is always going to be the deposit or loan. Rate is your percentage, your annual percentage rate. Convert that to a decimal. And then your time is always going to be in year unless stated otherwise. So you always want to convert it to year. All right. So that's where the PRT came from in the, in the red. We need to know, okay, what am I going to deposit in each account? That's the principal. The rate they gave to us, 15%. So I converted that to a decimal, it's 0.15, and then the other one, 7%. Convert that to a decimal, 0.07. And then we want to know how much are we going to earn in a year. So my time is a year. And we're doing that for both accounts.
Good morning.
Hey, how's it going?
I'm doing okay. What are you talking? Sorry for showing up late. What are you talking about right now?
We have a word problem that came up here. I can make sure you get that word problem before we leave. But we just started off with this word problem right here.
Okay.
Yep. So just don't let me forget to double back for you at the end of class. All right. So the problem is we don't know how much we're going to deposit as far as the principal is concerned. So what we would do, or what we can do, and it doesn't matter which one we call X, I'm going to call my 15% account X. I'm going to deposit X amount of money into that account. Now, I have $50,000 in total. Whenever they give you a total and they don't tell you how much is going to be, like they don't say half is going to be deposited here, half is going to be deposited here, or they don't say something like 3/4 would be deposited here or something like that. What you would do is call one of the deposits X, and the other deposit will be the total minus X. So our total was 50,000. I believe it was 50, not 5, right? Yep, 50,000. So our total is 50,000. So I'm going to deposit X in 15%. And then in my 70% account, I'm going to deposit 50,000 minus X. Once again, it doesn't matter which one you call X and which one you call 50,000 minus X. When you do all of your calculations, eventually you'll come up with the same answer. All right. Questions on the initial setup, the information that we have here before we go any further? All right. Also, don't forget, if I scroll up, but you're still copying, let me know.
Can you go up like to the 7% real quick?
So right here?
Yeah, you can go past now.
Oh, okay. All right. So now what we're going to do is, if you look at the box that I have down here bottom, try not to get too ahead of myself. Yeah, I don't want to do that yet. So the way we're going to calculate our interest is that we're going to have a total amount of interest earned. And we want to take the amount from the account that has 15% and the amount for the account that has 7%, add them together. And that's going to be the total amount of interest earned from each account. All right, so that's how we're going to set up our equation. We have an amount that's going to be earned out of the 15% account, an amount that's going to be earned out of the 7% account. When we add them together, that's going to be the total amount of interest earned from both accounts.
And she wants us to get to a principal or an interest amount of 6,000, correct?
Yes, yes.
What it was? I was trying to remember. All right, thank you.
Yeah, no problem. All right. So, and that's where we're going to next. The first piece of the information that we know out of that equation is what he just mentioned. Your total interest earned, we want to be 6,000. And then, excuse me, the next piece, the interest earned from the 15% account, is P times R times T. So remember our PRT, if you wrote it down, is X times 0.15 times 1. And that's how you get 0.15X. And then in the next one, do the same thing, but we have 50,000 minus X times 0.7 times 1. And we're going to distribute that 0.7. That's what I was signifying there to each term. And that gives us 3,500 minus 0.07X. So we'll take this 6,000, 0.15X, and the 3,500 minus 0.07X and plug it into this relationship right here. Any questions before we go to the next piece, next step? All right, so setting up our equation, that's what we have right here. Let me go ahead and delete some of this stuff. That's the 6,000, 0.15X, and then 3,500 minus 0.07X. All right, so before we go any further, question on the setup. So whenever you have an interest problem like this, Because you will see at least one like this. This is how you would do it. You would, like I said, use the PRT in order to calculate your simple interest. When you at this part right here, this relationship right here is the part that most people get caught up on. Once again, you'll call one x and then let the other one be the total minus x. That's what we did right there. Whatever that total value is. And multiply those three together to represent each one that's in that account, the amount of interest they earned for each count. So from there, we would go ahead and solve the equation, combine your like terms. So you would do 0.15x minus 0.07x, and that'll be 0.08x plus 3,500 on the right, equal to 6,000 on that left. Then you will subtract 3,500 from both sides. 3,500 cancels on the right. That'll leave me with 2,500. I guess I'll erase it. Walk through it. 2,500 equal to 0.08x. And then to finish it off, divide by that 0.08. And cancel them out. And that'll give us 31,250. All right. So always remember to make sure you actually answer the question. We wanted to know how much was deposited into each account. So coming down to X doesn't fully answer the question. Now X represents what was in the 15% account. And then to find out what is in the 7% account, you will subtract that 31,250 from that 51,000, and that'll be 18,750. So it's important to try these out on your own when it comes to word problems. And if you have a problem with a word problem, make sure you bring it to my attention. We can talk about it. And bring that one specifically because there may be something in that word problem that's triggering an issue for you, wherein I could pick up 5 word problems that I think is similar, and it still does not address the issue that you had with that specific word problem. So just make sure you take note of issues that you're having with certain problems so we can discuss that and make sure you're straight. All right, questions before we look at one more. All right. All right, so this next one, we have the length of an American football field is 200 feet more than the width. If the perimeter of the field is 1,040 feet, what are the dimensions? So I'll give you a chance to write it. All right, so we have a football field, American football field. You had to say American football field because worldwide football is soccer. So it's 200 feet more than width. And the perimeter of the field is 1,040 feet. What are our dimensions? So we're talking about a rectangle. If you don't play football, haven't seen a football field, we're talking about a rectangle. And so first thing we can do is establish well, let's go here. The perimeter formula is P equal to 2L plus 2W for the rectangle. So the rectangle perimeter is P equal to 2L plus 2W. So we need an algebraic representation for P, L, and W, and that's what I have over here. And so where did that come from? W, we're going to call X because the length is described in terms of W. So it says that the length is 200 feet more than the width. So that means we call the width X, and then we call the length X plus 200. And your perimeter is already given. That's 1,040. Once you have those three pieces, any questions on that setup, any questions on those three pieces, we call WX. The length is X plus 200 because it's 200 more than the width. So X plus 200. And then, like I said, they gave us the perimeter, which is 1,040. Then we go to our formula and plug in those values accordingly. So once again, P equal to 2L plus 2W. Plug in 1,040 for P, X plus 200 for L, X for W. All right. Now from there, you can go ahead and solve your equation. We'll distribute 2. And that'll be 1,040 equal to 2x plus 400 plus 2x. Combine your like terms, 2x plus 2x, 4x. Minus 400. 400 is canceled on the right. Then on the left, we have 640 equal to 4x. And then we can finish it all by dividing by 4. And x is equal to 160. All right, so to finish it off, remember, you always want to make sure you actually answer the question. Remember, this problem wanted the dimensions. So it wanted the width and the length. And so your width is equal to x, so that's just going to be 160. And then your length is 360 because you're going to add 200 to the 160. And those will be your two answers. All right. Questions on that? Make sure we're okay. All right. All right, so the last thing in this section is solving for a specified variable. So we have that same perimeter formula and we want to solve for L. We have P equal to 2L plus 2W. We want to solve for L. That means we want to get L by itself. And so we will follow the same procedures and the same process that we would as if all of these were numbers except for the L. So in other words, if we go over here to the 7 equal to 2L plus 5, if I wanted to get L by itself, if I wanted to solve for L, the first thing I would do is subtract 5 from both sides. So that's the same thought process I should have here. I would treat all of these other variables the same way I would numbers. And this means I would subtract 2W from both sides. 2W on the right cancels. And I cannot combine P and 2W. They are not like terms. So what I'm left with is P minus 2W equal to 2L. All right. Then I want to get, still want to get L by itself. So I would divide both sides by 2. 2's cancel on the right. And that leaves me with P minus 2W over 2. So questions up to that point.
Can you scroll up to the first red box before 5 equal X? Yeah.
Okay. So now that is our answer. But I want to make sure we're clear on something before we leave it. And that's why I had those arrows going to other things I'm going to talk about reducing when you don't have to and what you could do if you decide to. But I just want to make sure everybody's caught up with us before we go any further. All right, so we have as a final answer, P minus 2W over 2. Now, what a lot of people would like to do is to reduce further because they see 2's that are in common. You can reduce further, but I just want to make sure that you do it properly. So when you go over here up top, notice I have this and I said INC, but I was doing it for incorrect. And that still don't look so much better. Anyway, what you cannot do is just cancel out the 2's and have P minus W. And I know a lot of people want to do that. They just want to cancel out the 2's and then walk away from the problem. So you cannot just cancel these 2's and have P minus W as a final answer. So the bottom arrow right here is the correct way of doing it. You have P minus 2W over 2. That 2 has to go into each term in the numerator. So whenever you have something like that, you have multiple terms in your numerator, the denominator has to be distributed to each term. And so that's why you have P over 2 minus 2W over 2 now. And now if you want to cancel out those 2's, you can. And so you have P over 2 minus W. And that would be another way of representing that final answer. But because that 2, notice that we still have a 2 in our denominator. Because that 2 couldn't simplify completely into the problem. So since that 2 couldn't divide into each term in the numerator, you can leave it. You can leave it like this and still be fine. Now, if that 2 could go into each term evenly or divide into each term evenly, then you are expected to do it. So in other words, if you look over here in the green, I called it a random example. This has nothing to do with the problem we're dealing with. This is just an example. Notice if I have 4P minus 2W, this 2 can divide into the 4 and to the 2. So that's something you are expected to reduce. You must reduce something like that because the 2 can divide into each term. And notice that'll be 4P over 2, 2W over 2, and dividing those 2's, that'll leave you with 2P minus W. So something like this, you are expected to reduce because the 2 can divide into each term evenly. Once again, when we initially had, you didn't necessarily have to because there was nothing in front of the P that the 2 could divide into. So before we go to another problem, is everybody clear on that? Make sure we're okay. Questions? All right. All right, so let's do this next one. So we have A equal to P plus PRT, and we want to solve it for P. All right, so we notice that we have P in two different terms, two different places.
Hey, Professor.
Yes.
Just for kind of like, just to make it easier, do you mind making that T a capital T so that way I don't get it confused with like a plus symbol? Anything like
Yeah,
that?
I would, but they're not going to do that when you go in
Okay.
my math lab. And that I'm glad you brought that up. And that's very key, because what's going to happen in my math lab, you're going to have some that are going to be capital, some that's going to be lowercase. And if you were to, let's say if we, in this case, we have lowercase t, if you want to do that in your notes, that'd be great. And I don't have a problem with you doing that. But if you were to type in a capital T in my math lab, they would mark it wrong, because it is case sensitive. Because in mathematics, a lowercase x and a capital X mean two totally different things. Same thing with a lowercase t versus a capital T. Where in lowercase t will equal to time, capital T, does that change the time? Anyway, this just represents something totally different. And, we only have like 26 letters. So eventually, we start doing different things so that we have more options for our variables. So, yeah. So just throwing it out there, always make sure you hold true to, and that's why I tried to put that little curve at the end of the T instead of making it straight. I try, and I know that it's something that is easy to get confused with, but I do want you guys to get used to the idea that these variables that they give you are case sensitive, and using a lowercase value when they use a capital and vice versa, they will mark it wrong, and then you be trying to figure out what's wrong with it, and all it was the case. So I'm glad you brought that up. Yeah.
Sorry, Professor, can you go up a little bit? I just gotta see something real quick.
Let me know when to stop.
Just a little bit more. Okay. Why is that an X and 5?
Oh, you're talking about right here?
Uh-huh.
Oh, somebody had asked a question. That was from the previous class. That's just saying that 5 is equal to X and X equal to 5. They're the same thing. Yeah, I was talking to somebody. Really, that has nothing to do with this problem.
Okay.
Yep, that has nothing to do with anything. Yep. All right.
Okay, thank you.
Yep, no problem, no problem. All right. So back here we have A equal to P plus PRT. And notice we have P in two different terms. So what you should do is go ahead and factor P out. So I pulled P to the outside of my quantity, and that left me with 1 plus RT. All right, and if I were to distribute this back, I get back P and PRT. So that's where that comes from. I just pulled P out of each one of those terms. And it leaves me with A equal to P times 1 plus RT. And so from there, I divided both sides by 1 plus RT.
You said it's P plus 1 plus RT?
Unless I said it wrong, it's P times 1 plus RT.
Why does it become a times?
Factoring. When we talk about
What?
factoring, let's say if I have, let's say 5x plus 10, I want to factor out 5. I can pull 5 to the outside, and that leaves me with x plus 2. So that's 5 times x plus 2.
Oh.
Yep. And so if I want to distribute this back, that's 5x plus 10. So it's the same thing that I had. That represents the same expression that you had originally. It's just that I factored out 5. So the same thing happens here. Factoring is the reversal process of multiplication, or the reversal process of distribution. So if I have P plus PRT, when I pull P to the outside, I'm left with 1 plus RT inside of the parentheses. Now, once again, if I were to multiply this back, P times 1 is P, P times RT is PRT. So it's the same expression, but I have P factored to the outside. So what that does is that it gives me a single P. Remember, your goal is to solve for P. You want to get P by itself. So that gives you a single P instead of 2 different P's in 2 different terms. And now that's, like I said, that's P times RT, P times 1 plus RT, if I can get it out. Now I can divide both sides by that quantity of 1 plus RT. Now that quantity of 1 plus RT will cancel. And that leaves me with P equal to A plus, what, A over 1 plus RT. So yeah, that would be the answer.
Professor, I'm sorry if I missed it, but what does the what does the A stand for?
It actually represents future value. It doesn't matter in this case. They're just giving you random variables, and they just want you to solve for the variable that they ask you to solve for.
Gotcha. Thank you.
Yeah, no problem. But in interest, it is an actual interest formula, and A represents future value. All right. Questions? Any questions? That was section. Okay, let's do one more. All right, so let's solve this for H. We have A is equal to 2LW plus 2LH plus 2WH, and we want to solve for H. So we have H in 2 different terms. So our goal should be to get all of our terms with H on one side, all of our terms without H to the other side. So our 2 H terms are on the same side, so we're fine. But we can take that 2LW to the other side. I'm just rewriting the problem here. And we're going to minus 2LW from each side of the equal sign. And that is A minus 2LW on the left, and on the right, 2LH plus 2WH.
Just out of curiosity, Professor, why aren't we dividing 2L8 or 2LW, and why are we subtracting it?
Because what was going on in the original problem is that it's being added.
Mm-hmm.
Yeah. So now if it was being multiplied like this, then that's when we would divide.
Gotcha. All right. Thank you, Professor.
Not a problem. All right. So now we have a similar scenario to what we had last problem. We have H in 2 different terms. So we want to factor out H. We want to pull H to the outside. So bringing H to the outside, that leaves me with 2L plus 2w in the parentheses. And now we can divide both sides by 2L plus 2W, because that is H times 2L plus 2W. So we'll divide both sides by that quantity. So that quantity will cancel. And that leaves us with A. And I see somebody in the chat. I'm going to come to you in a second. Let me write this. All right. So the other H, when you factor, when we went from this step to this step, I pulled that H out of each term. So that H represents that same H that's in both of these terms. Because if I wanted to distribute this back, then that would take us back to this original expression of 2LH plus 2WH. But what I did was I reversed that by bringing them both of the H's out front and turned it into multiplication. So that's where both H's went. Both H's went right here. And then, like I said, if I wanted to reverse the process, I can multiply it or distribute it back. And then that'll take me back to what this is. All right. Questions on that? Questions? Any questions? 1.4.
Hey, Professor,
Yes.
so the answer is A. It's A minus 2LW, correct?
Did I leave off W? Yes, thank you.
Okay,
Left the
I was just
W
making
out.
sure I didn't lose something. All right, thank
Oh,
you.
no, I appreciate that. Thanks. Yep. So just in case you missed what he was saying, I may have written it quick. So this W I had left off initially. So it's A minus 2LW over 2L plus 2W. All right. So let's start 1.4 and talk about complex numbers. Not going to try to finish it, but I do want to start it. At least it introduce the concept to the class before we close out today. So 1.4 is complex numbers. So our imaginary unit is the square root of -1. Square root of -1 is going to be I. So when we're talking about taking the square root, erase some of this stuff. Whenever you're taking the square root of something, remember you're asking yourself what times itself twice will give me the number under the radical. So when I look at the square root of 25, you say what times itself twice will give me 25? And that is 5. And that is because 5 times 5 is 25. Same thing with the square root of 81. Square root of 81 is 9 because 9 times 9 will give me 81. Square root of 121 is 11 because 11 times 11 will give me 121. Now, when you're talking about the square root of -25, there is no number that you can multiply to itself twice that will give you a negative number. We know 5 times 5 will give me positive 25, but also -5 times -5 will give you a positive 25. So that's where this comes into play, this imaginary unit. Whenever you're taking the square root of a negative, you can implement that. So, and you don't have to write this step out every single time, but this is what's going on here. You can look at the square root of 25 and then the square root of -1. Square root of 25 is 5, like we just mentioned, and then the square root of -1 is I. So whenever you have the square root of a negative, just know that I should be involved as a part of your calculation. All right, so it means the square root of -81 is going to be 9I. Square root of -121 would be 11I. So whenever you're taking the square root of a negative, the negative is under the radical, then I should be involved. Any questions? Also, when dealing with our radicals, you may have something that's not a perfect square, but they are expecting you to reduce it as much as possible. So when I look at the square root of 18, that's not a perfect square, but I can break it up using the numbers 9 times 2. 9 times 2 is 18, but I can take the square root of 9, and that's what I want to do. I want to see what's the largest number that's a factor of 18 that I can take the square root of. So I couldn't use 6 times 3 because I cannot take the square root of 6 evenly, cannot take the square root of 3 evenly. And if you're having problems with what you can take the square root of, what you cannot take the square root of, that's fine. Just use your calculator. The more you use it, the more you get familiar with those terms that are perfect roots, the less and less you'll need the calculator. So you look at your factors of 18. If I were to look at the factors of 18, we're talking about 2 times 9, well, 1 times 18, 2 times 9, 3 times 6. The only one that has a perfect square that's not 1 is 2 times 9, and that's that 9. So like I said, if you're not used to dealing with perfect squares and everything, it may take a little while to get comfortable with what is a perfect square and what's not. And of course, if you ever have a question, just put in your calculator, take the square root of it, and see if it comes out with a solid number. So what happens here is that now I have the square root of 9 times the square root of 2. I can break them up. Take the square root of 9. Square root of 9 is 3, because 3 times 3 will give you 9. And then leave your 2 under the radical. All right, and that will be your most simplified way of expressing the square root of 18. So the same thing happens if I have a negative under the radical, square root of -24. I will look and see what's a factor of 24 that's a perfect square. So I can break that up into -4 times 6. All right, so square root of -4 is 2i. And then the square root of 6, you cannot break up any. So you can write it like that, or some books may write it this way. Either way is fine. But remember, taking the square root of a negative, an I has to be used, and then the square root of 4 is 2. All right. Questions? Any questions? And this was just another one. We had the square root of 500. So I broke it up into 100 times 5, took the square root of 100, which is 10, and left the 5 under the radical. And then in the second was the same problem, but somebody asked me about another way to go. So I decided to use 25 times 20, which is still 500. Took the square root of 25, which is 5, but the square root of 20 still could be broken down further. And that's what happened right here. because the 4 times 5 is still 20. But then I broke down the square root of 4, which is 2. And then 5 times 2 was still 10. So I was just showing them that no matter which way you do it, if you break things down all the way to a simplest form, eventually you'll still get the same answer. So it's just 2 different ways of doing it, even if you don't find the largest factor of 500 on the first go round. If you keep breaking it down, you'll still get the same answer of 10 square root of 5. All right. Questions. All right, so last thing for today, complex numbers. So complex numbers will take on the form of a plus bi. So you have your real part and your imaginary part, and you always write that real part first. So a few examples over here on the right. You have 2 plus 5i, negative 1 plus 3i, 7 minus 10i. Then I say 8 can be written as an imaginary number, or a complex number, excuse me, not as imaginary, but as a complex number, just 8 plus 0i. And then negative 12i. You can write that as 0 minus 12i. Real part would be 0. All right, so adding and subtracting complex numbers are just combining your like terms. Yep, and that's where we'll stop today.
Sir, can you go back up, please?
How far?
Just to the example.
This one?
Yes, sir.
Mm-hmm. All right. Are we good to go?
Yes, so I have a question. So the other examples are like, they're different. Like, it's just different examples.
When you say other examples, are you talking about in the green or?
Yes.
Yeah, that's just different ways of writing a
Okay.
complex number. Mm-hmm. Yeah, I was just giving you
I'm
examples of
confused.
complex numbers.
Thank you.
Mm-hmm. And let me write that together. All right, where that looks. All right. So yeah, they were just random examples. And so for here, if I want to add and subtract complex numbers, all you're going to do is combine your like terms. So if I have 5 minus 11i plus 7 plus 4i, I would just do 5 plus 7, which is 12, negative 11i plus 4i, that's negative 7i. So this takes you back to regular algebra when you're combining your like terms. Then when it comes to subtraction, don't forget to distribute this negative first to each term in the parentheses. So that'd be negative 5 plus I plus 11 plus 6i. It changes the sign of each term. And then combine your like terms, negative 5 plus 11, and then positive 1i plus 6i. So you'll get 6 plus 7i. All right, questions. Make sure we're okay.
I had a question about something different. So
Mhm.
can I talk to you after class about that?
Yep. Yep. All right. Any questions on anything before we close out? Got it good. Everybody straight. So this is just a good place to start.
I'm sorry, I
Uh,
have a question.
mhm.
Am I able to save the work for later in math lab?
Yes, you should be able to. If you're talking about your homework, right?
Yes.
Yeah. When you go in there, it should be a save button. And when you
Okay.
get in there, yep, you can pick up where you left off next time you come back in.
Okay, thank you.
Mm-hmm. All right. So next class, we'll start here. We'll get into multiplying your complex numbers. But yeah, I think it's a good place to stop. So make sure you guys get into your homework, get into my math lab, see if you have any issues. You know, if you have any questions, make sure you ask them. And we'll go from there. So I know I have to stay back with a few people. Outside of that, you guys have a great weekend and be safe. See you on
So
Monday.
real quick, sir. So for Monday, we should have 1.2 done. We should have 1.3 and be into 1.4 by Monday's class.
If you're gonna keep up with the
If you're
lectures,
staying with, yes.
yeah,
Okay.
if you're staying with the lectures, yes, you should be
All right.
touching 1.4. Now, it's not mandatory that you stay that connected to the lectures, but I mean, that is the best practice. That should be the goal for everybody.
Excellent. Thank you.
All right, thank you. All right, let me stop the recording and then I'll see what other questions we got going on.